Okay, in this video, I'm going to walk through several more trig equations, solving trig equations. The ones that I've selected to discuss or at least look at are in this list here, 11 through 75. And this first group of five and the last group of five are the optional homework assignments that I gave you over the last 2 days, day 60 and day 61. This group in the center did not show up in any of the optional homeworks for this week, but it's kind of an interesting method that I'm going to show you today in solving, so you might want to see these as well. So in problem number 11, and I'm just going to jump down here and start writing these out. In problem number 11, we had 2 sine theta plus 3 equals 2. And I would suggest that you solve this without a calculator. We can subtract 3 from both sides. We have 2 sine theta equals -1, then divide by 2 on both sides. And we now know that sine theta has to equal to -1/2. Now, consulting our unit circle, well, where does or what angle measure on the unit circle contains a y value of -1/2? Well, that's these two positions, and this angle measure is the first angle beyond horizontal. So we know that theta is 7 pi over 6. And then the second solution is this position, the last angle before horizontal again, and we'll call this one 11 pi over 6, and we've got our solution. But the purpose of this video is to show you how we might obtain this using a calculator. Now, I'm not going to use the TI calculator for this. It's a bit too cumbersome, especially since you're on home instruction. Not all of you have one. But I do think that using Desmos might be a good tool here. So first things first, I'm going to make sure that my calculator is in radians, since most of our solutions are to be recorded in radians, and it is. And so what I want to point out to you here is really a couple different ways to solve this. Now, we did our algebra and got to this point, and we knew that sine of theta had to be equal to -1/2. So I'm going to start there. So jumping back into Desmos, I'm not going to use theta. I'm going to use the letter x, since our x-axis is already well defined for us. But inside the keyboard on Desmos's site, we can click on Functions, choose Sine of x, and there's our familiar sine graph. But what I wanted to point out to you here is that if I include our squiggly braces, which you can type with a regular keyboard, or if you jump into the ABC Desmos keyboard, these are the ones that I'm talking about here, this will allow us to restrict our domain. So I'm going to say that we only want solutions between 0 and 2 pi. And so what this does for us here, whoops, there we go. What this does for us is it provides our graph. Now we're not looking at a unit circle anymore, but it provides our graph and the results for sine along all x values between 0 and 2 pi. Now, while I'm here, I'm going to make this a little bit more meaningful. I'm going to jump into the settings again. And I'm going to specify that the step on the x-axis is pi over 2. So I'll choose pi, divide it by 2, and that gives us a really nice, very clear series of demarcations for us along the x-axis. Now here again, what I was worried about, or what we were looking for, is when does sine of theta equal -1/2? And some of you might be thinking to yourselves what I might be about, or what what I might be doing next. So I'll type y equals -1/2, and now we see a line that represents the value -1/2, and anywhere that this line intersects the sine function, well, that represents a solution to our original problem. And sure enough, the solutions 7 pi over 6 and 11 pi over 6 are also revealed on this graph. And so that's a nice way, if you have technology available, to find a solution. And if you practice well enough, then you might be able to use this a little bit faster than solving by hand. Personally, I think it's a bit of a toss-up, but at least it's an option. So the next question I wanted to look at was number 16, and it looked like this: 4 cosine squared minus 3 equals 0. And this one's kind of fun, but we could use the quadratic formula since this is a quadratic format of a trig question, or we can just use square roots. And I think that's the method I'm going to go through here. I'm going to add 3 to both sides and then immediately divide by 4 after that's done. And I'm going to be left with cosine squared theta equals positive 3/4. Now, in order to get cosine theta by itself, I'm going to have to take the square root of both sides, but you've got to be careful here. Since the square root symbol was not included in the original problem, we've got to be prepared for both a positive and negative solution. Now, as it turns out, the square root of 3/4, let's remind ourselves, would be the same as the square root of 3 over the square root of 4. And since the square root of 4 is a nice result, we'll come back here and say that we're talking about the square root of 3 over 2. So we've got a positive or negative square root 3 over 2 is the result for cosine. So if we think of a unit circle to help us find the solution here, where is the x value in our unit circle equal to a positive square root 3 over 2? Well, that's here. Whoops. And here. And where is our x value equal to a negative square root 3 over 2? Well, that's here and here, and those positions can be easily identified. So our first position after horizontal in the first quadrant is pi over 6. Our last position before horizontal is 5 pi over 6, then 7 pi over 6, and finally 11 pi over 6. And of course we can check this by using a calculator. So I've already done that in Desmos off to the side here. Again, I've graphed the cosine function and I've limited it to angle measures between 0 and 2 pi. I've graphed y equals positive square root 3 over 2 and y equals negative square root 3 over 2. And the positions for those intersections, both on the green and blue graph, let's see if I can get those all to show up here, are pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6, exactly as we discovered back here. Now this method is particularly helpful, and I'm going to jump ahead here, for problems like 45. In number 45, we're asked to find when does sine of theta equal 0.4. Well, I don't know the unit circle well enough to say when is there a y value equal to 0.4. Now, if it said 0.5, I'd be okay with that. But 0.4, I just don't know. I don't know this angle measure, and I don't know this angle measure. But both of those would contain points that had a y value equal to 0.4. And so for that reason, I'm going to switch to the graphing calculator. So if I have the function sine of x on the domain from 0 to 2 pi, again, we're talking about this sine curve, this sine wave between 0 and 2 pi, and we want to know when does this function in purple equal 0.4. Well, y equals 0.4. Well, that occurs here and here. There are 2 positions, just as I had suspected with my unit circle, but now I've got a value for them, and they're not, these are radian angle measures, but they're not nice radian measures. They're not written in terms of pi, and that's okay. 0.412, so we can say that theta is equal to 0.412, and we can also say that theta is equal to 2.73. Now, if you need more precision than that, these are only 3 decimals and 2 decimals respectively, then you could also keep in mind that with sine theta equals 0.4, if I apply sine inverse to both sides of the equation, that's going to allow the sines to cancel here, and we'd be left with theta equals whatever sine inverse of 0.4 is. The trouble we have there, when you evaluate sine inverse at 0.4, if your calculator set to radians, you'll get one solution. Here's that 0.412, which in actuality is 0.4115. But you don't get the second answer. And to obtain the second answer, well, you've got to be kind of thoughtful about it. Again, the 0.4 radians was this position right here, and the rotation from horizontal positive x-axis to this position is going to be the same as the rotation from negative x-axis to this position. So while we're sitting at pi perfectly horizontal from here, we're just a little bit less than pi landing on that position. So if I take pi, 3.14 with a couple extra decimals, and subtract 0.4115, then there's the remaining value, 2.301 in this case. 2.30, sorry, 2.7301. So we can get additional precision that way by including as many decimals as needed. So I'm going to stop this video here and probably record another one to help you out with some additional questions.